Welcome back. In this video, we're going to pick up where we left off with part 1 of bug. Here is our public interface. We knocked out these two constructors as well as the turn method and the toString in the last video. So if you have not seen that one, definitely check it out. We're going to pick up by coding these move methods, and these can be pretty intense. Let's get started. Okay, here I am in IntelliJ. I'm going to flip back to our driver for just a moment. You see that we're making a bug, and the bug's world length is 10, and the bug is starting in position 4. So this is one of the overloaded constructors that we wrote. We print off our bug to see its initial state. Keep in mind right here, we are implicitly calling bug.toString. Right, and our toString method is where we kind of go through and piece together that string. Initially, I start out with an empty string, but I'm going to loop based on the world length. If the current position is the bug's position, I'm going to insert whatever the current bug character is. Right, this is just simply a char. We're using basically angle brackets to kind of represent our little bug and which way it is facing. Otherwise, so if I'm at any other spot, we're going to do an underscore. And I do this inside of the loop. After the loop is finished, I basically have traversed the world, if you will, and I end up returning that string. So that's what happens with our toString and how we get that string representation. The next thing I do is tell my bug to turn. If we look at our turn method, we check if we are facing to the right. Right, this is just a Boolean instance variable. Then I'm going to basically want to face the other way. I'm going to change facing right to false, indicating that we are facing left. And I'm going to change the character that I'm using to represent my bug. And this is ultimately why we're using a variable to store our bug character, is that it could, in theory, change over the life of the object. If I'm not facing right, that is, I hit this else, I am facing left. And so we're going to set facing right to true. I want to turn to the right. I am currently facing left. I want to turn to the right. And then we update our bug to indicate that. So that's what happens in our turn here. Initially, we are facing to the right. And so when I call bug turn, we face to the left. If I call it again, we face the other way. Okay, so we're basically ready to start the move methods. It doesn't matter where we insert these things, but based on the public interface, somewhere in here looks pretty good. And what I actually recommend is we do this one first. Right, just like we did the constructor that took in the highest number of parameters, I'm going to do the move method that takes in the highest number of parameters. We're going to go public void move. It's going to take in an integer, and that integer is the number of spaces. This is a perfect method to JavaDoc, so let's do so. I'm going to do /***. We are going to move the bug object in amount equal to spaces. Right? The fact that I've named it here and it's listed here as a parameter, I can just refer to it here. The bug moves forward if spaces is a positive number, and backwards if spaces is negative. Okay, so what this means is if we're facing to the right and we enter a positive number, we're going to move to the right. If we're facing to the left and I enter a positive number, I'm going to move to the left. But what this is indicating is that spaces could possibly be negative. Right? So if I'm facing to the right and we get a negative number, we're going to actually back up. Let me see if I can demonstrate that by switching back to my other bug project. And I'll do it in a new window so I don't lose my current one. Fortunately, my a lot of my source code here is covered up in the bug class. Why don't we run this thing? Okay, so here's my bug in position 0, and I'm going to select 2 so that we can move in options, right? I'm going to move like 3 spaces, and we see that we are facing to the right, enter a positive number, I move to the right. Okay, if I move again and I do -3, I should end up back in the same spot, right? But still facing to the right. There we see it. Our bug basically went the other direction. That's what I mean by that, okay? Now, if we turn, right, and we do a move here, and I'm going to do -5, we're actually going to move to the right, but I'm facing to the left, right? So it's as if the bug is backing up. That's what I mean by all that. Okay, more to this Java duck. If the bug were to leave the world, the bug wraps around to the other side. Post condition. 0 is less than or equal to position, which is less than world length. What does this mean? Position is the position of the bug. I'm saying that after this is over, that position must be greater than or equal to 0, meaning we're still going to be in bounds. And what it's saying over here on the other side is that we still have to be less than world length. Basically, position has to be in this number range. That is what this post condition is indicating. And comments like these are actually very common on the AP CSA exam. You'll see stuff like this that indicate, that position will be in this number range. And that's kind of in line with what we're saying here, that if we wrap around, we're still going to be in bounds. That's all this is saying, but we're expressing it kind of mathematically here in a comment. Okay, more to this. I'm going to kind of come over here. Facing right is unchanged. We're not going to turn in the process of doing this. Bug is unchanged. Okay, here, notice the lack of capitalization. When I say facing right and I say bug, I'm referring to variables, specifically these instance variables. All this is saying is that this method, it doesn't change these things. That's all. That's all we're saying. Now, you could, in theory, change them and then change them back, but once the method is over, they're going to be what they originally were. That's all that this is saying. Okay, param is amount of spaces to move, can be positive or negative. Okay, let's dive into this move method finally. And I'm going to kind of build up an approach that I would suspect most students would go with. And then we're going to scrap that and then look at another approach, which I would consider pretty big brain. So in order to do this, I find the best way to work through this is by using an example. So let's kind of establish a starting state for our bug. Let's use this effectively. I'm going to copy that bad boy and paste it. That was unplanned, but worked out brilliantly. Right here in this example, our position is 4, and our world length is 10. Okay, maybe something that'll help us here. And 10 is a really good world length because it makes it easy to number these things as such. Right here, it makes it a little bit easier to see that we are in position 4, and our total world length is 10. We're going to use this as a working example in order to develop these things. Let's basically do a call to move, and let's say that we're going to move, 4 spaces. Okay. The first step to really changing this or really updating this is all we have to do is take our current position and increase it by this amount, right? I want to go from 4 to 8. How would I do that? Well, I would want position to be what it currently is plus this amount, which is going to be spaces. Right? What we're looking at is our current position. In this example, it is 4. And I want to add spaces, which is 4, meaning our new position would be 8. As a result, it should look something like this. Right? And we won't really see that until we call the toString and render it again. So I'm actually going to go ahead and try this out. I'm going to flip back to my driver, right? And we're going to lead with that example. We're going to begin in that position. Why don't we go ahead and call our move method? I'll take the bug and I'll tell it to move. Hopefully here you're starting to see between turn and move, you see what we mean when we say methods represent behaviors, actions that can be performed like turn or move. Here I'm going to move 4. And then let's see what our bug looks like as a result of doing that. I'm going to run my driver. And there we go. We are in position 8. Easy. World's easiest move method. Okay. What happens when we go out of bounds here? Right? That was with a move of 4, but let's try like a move of 6. If I move 6, position 4, our initial position is 4. I'm going to move 6 spaces. My new value is 10, which puts me right here, out of bounds. So what I want you to think about is, where should we be? If I'm in this exact scenario where I'm in position 4 and I move 6 spaces, I want to be here, right? I want to go 1, 2, 3, 4, 5, 6. Okay, so I think one thought is, how do we get from 10 to 0? Right? If I was to move 7, I would end up at position 11, which is here, well out of bounds. Where I want to end up is position 1. So the next thing I want you to think about is some type of mathematical relationship, and I think students tend to get there. It's, let's take that position, and if it is too far out of bounds, if our position is out of bounds, right? The way that I know that's out of bounds over here is if it is greater than or equal to our world length. Keep in mind, our world length is 10. If that is true, just simply subtract 10 from it. Okay, let's follow the rest of this example. Right? At this moment, we're saying, is position, which is 11, greater than or equal to our world length, which is 10? It is. I would enter this if statement, right? And we're going to update our position. It's going to be what it currently is, which is 11, minus our world length. The new value for position is 1. That sounds perfect. So I'm going to leave this code in. We're going to try to move our bug 7 spaces instead. Keep in mind we're starting at position 4. 7 would put us at 11. I want it to wrap back around to position 1. And let's try that. So that looks pretty good, right? Okay. What if this is like 17 spaces? All right, I'm starting at position 4. I want to move 17 times. We're well out of bounds. Okay, so this is kind of the right idea. The problem is, what if we got to wrap around multiple times? Right? What if we go excess? Right, so what's happening is I'm passing in 17, so we're taking our position. We're going to move 17 spaces. That puts us at 21. We're going to ask, is 21 greater than 10? Yeah, so we'll enter this if statement. We'll take 21 and we'll subtract 10. That puts us at position 11, and we're done. What I hope you recognize is, what if we just did that again? Okay, and this is actually a simple change. Right? We say while our position is greater than or equal to world length. Let's check this out. I'm going to do move 17. Our initial position is 4. 4 plus 17, that gives me the 21. I'm going to say while position is greater than or equal to world length. Right? We're asking, is 21 greater than or equal to 10? It is. So I'll take that position, I'll subtract 10, giving me 11. Because this is a while loop, we'll come back up and ask the question again. Now we're asking, is 11 greater than or equal to 10? It is. we're going to take 11, subtract 10, giving us 1, which is where we actually want to be. So I'm going to run this code, and we're going to kind of see that it works. Now that I've just simply changed that if statement to a while. Ta-da. Okay. Now, this is what I want to do if we're facing right and if spaces is positive. I'm not even going to really deal with the positive negative thing right now. I just kind of want to get a solution to be built. So basically, I want to do these things if we're facing right. Okay, so I'm going to basically just plug in an if statement to say if we are facing right, let's do this. Let's go ahead and take out these comments. Just like so. And I know some of you have probably been screaming at your monitor. This can be basically reduced to just simply saying plus equals. Those are the exact same thing, right? So I can say plus equals spaces. Same thing here. This could be simply, we can just use a shorthand assignment operator and say minus equal world length and achieve effectively the same thing. So if we're facing right, we just add spaces. And there we go. That easy. Okay. Now, I basically want to do this same thing, but if we're facing left, right? So I'm actually going to copy this. And as you might imagine, we need to change some things. All right, how do I know? I'm going to use this to kind of decide if we're facing left or not. How do we know that we're facing to the left? Well, it's if facing right is false. So one way to check that is to say is equal to false. You see IntelliJ basically highlights this right away, saying this could be replaced by not facing right, which I think makes some grammatical sense, right? If we are not facing right, that means we are, in fact, facing left. So if we're facing to the left, right, I don't want to just simply add spaces. I want to actually subtract those spaces to kind of decrease our position, right? So let's change our character. We can say that we're in the same spot. If I move, say, 3, oh, numlock's not on. If I move, just say 3, right, we're going to go 1, 2, 3 is the idea. So I'm actually subtracting spaces in that case, right? This looks pretty good, but maybe we're adding our world length instead, right? I'm just basically swapping the other things. I'm going to try this out. I'm going to go ahead and tell you this isn't quite going to work. We're going to see why, right? If we're facing to the left, we subtract spaces, and if our potential to go out of bounds is over here, right? So I want to basically add world length back to push me back in bounds, if that makes sense. I'm going to say that again. So we're facing left. I'm going to subtract spaces. So our potential to go out of bounds is this way, right? So I'm going to add world length back to push us back in bounds. That's the idea. I'm going to flip over to my driver. I'm going to create my bug. Right away, I'm going to turn it. So the very first time we see our bug is going to be facing to the left. There, tell it to move 17. That doesn't look good. What about just 3? 3 looks fine. Let's figure out where we're going wrong. Okay? And what I really want to do is see that when I do something ridiculous like 17, what is my actual position? Right? All I see is this. So is my bug just gone? Really, it exists either out of bounds to the far left or out of bounds to the far right is technically a possibility. I need to know. What I really need to do is see what the position is. As it stands right now, I don't have a way of seeing that. Position is a private instance variable inside of the bug. If I want to pull it out my driver to see what it is, I'm going to need an accessor. I'm going to need a getter. It doesn't matter where we put this, but logically to me, getters and setters go right after the constructor. So here, I'm going to auto-generate our code by doing Alt-Insert on a getter, just a getter. And the one I'm going to select is my position. I'm going to hit OK, and there it is. Just a simple getter for position. I want to use this, so I'm going to flip back to my driver. And right here, I'm going to plug in like a space, and then we'll ask the bug for its position. Right? I know it's not there. This will tell me where it's at. Maybe we, I don't want to put like a negative. No, that's probably good. All right, let's run it. I'm at a negative 13. What happened? Right? Let's step through this. So we are facing to the left, so this is going to trigger. This is one reason I like to expand these things, is because when I'm talking about it, right? Our current position is 4. And we are going to subtract 17 spaces, right? So this is 4, but this is a negative 13. Okay, that's what we're getting there. We're going to ask, is negative 13 greater than or equal to our world length? No, right? This isn't the problem, right? This is supposed to help us stay in bounds, and this check isn't quite right. I need this to be in relation to my lower bound, which is actually 0, right? So if our position is less than 0, okay, let's follow through with this. I'm going to move 17. We're currently at 4. So we're going to do 4 minus 17. That gives us a negative 13. We're going to ask, is negative 13 less than 0? It is. So what we're going to do is take our, it's supposed to be adding, right? We're supposed to take our position, which is negative 13. And I want to add world length, which is 10. Okay? That's going to give us a new value of negative 3. We'd come back up and we would ask, is negative 3 less than 0? It is. I'm going to take negative 3 and I'm going to do a positive 10. That puts us at a positive 7, I hope. We're going to ask, is 7 less than 0? It is not, so that's the point where we would stop. And our final position is 7. Okay, let's try that out. So I'm just going to let the code changes in there stick. And there we go. So this is basically the gist of the program. I'm going to maybe try doing negative numbers. I haven't really thought about them too much on the spot. But the question is, like, what if we put in a negative number? Let's see how it currently functions with maybe something a little bit easy. Let's just do like a negative 2, which should put us here. This may actually just work without having to do anything. Oh, yeah. Okay, so that looked pretty good, right? Negative 2, we just moved back 2 spots. What if this number is much larger? What if it's like negative, let's do negative 21. Uh-oh, ended up at a positive 25. Let's see what happens. So what I did was negative 21, right? We are facing to the left. So we're going to do this. We're going to say our position, which is 4, minus our spaces, which is negative 21, right? So this is really 4 plus 21, which is going to give us 25. No need for a calculator with. Okay, so when I get down here, my position is 25. We're going to ask, is 25 less than 0? It's a bit of a problem, right? Okay. So here's what I want to do. I kind of want to scrap this approach. This is pretty good, right? And if you could finish this out, more power to you. But I want to show you something a little bit big brain. I'm going to get rid of all this. And what I'm going to do is kind of talk to you about modulus. Because as it turns out, anytime you're in a wrapping around situation, modulus is awesome. And simply put, in order to keep it in bounds, in our example, like 10 is the length of my world. And so I ultimately want to use mod 10 in order to keep this thing in bounds. Let me show you the formula. We're going to update our position to be what it currently is, plus our spaces, modded by the world length. Okay. If I look at precedence here, this would actually happen first. So I'm going to use parentheses to make sure that our addition happens first. Let's see what happens with this formula, and you'll see why this starts to be pretty awesome. Right? We're going to update our position. It is going to be the current position, which is 4. Let's use some type of method call. Let's do move, something simple first. Let's do like move 3. Okay. And I'm going to go ahead and face my dude to the right. We're going to move 3 spots and then mod that by our world length, which is 10. So I have 4 plus 3, which is going to give me 7. 7 mod 10 is 7. Okay, what's happening here? Well, mod, if you recall, is division, except we get the remainder. We're going to basically ask, how many times does 10 go into 7? None. What are you left over with? 7. So that is the new position here. So you see, with a number that's smaller than 10, we get effectively the same result. I'm going to move to this position, effectively moving 3 spaces. Okay, let's go with a bigger number. Let's do like 6. My current position is 4. I'm going to move 6 spaces. This is going to give me a value of 10. 10 mod 10 is 0. 10 will go into 10 one time with a remainder of nothing. What that's going to do is take our position and we're going to move 6 spots. 1, 2, 3, 4, 5, 6. You see, this would normally push me out of bounds, but the mod is wrapping me back around to this spot. Okay, let's bump this up. 8. 4 plus 8, that's going to give me 12. 12 mod 10 is 2. Right? 10 will go into 12 one time with a remainder of 2. Let's actually see this in action. I'm going to reset my bug. We're going to be facing to the right. I'm going to move 8 spots. And we should be in position 2. Awesome. Okay. One of the things that's so cool about mod is if you amp this number up. Right? If we do 4 plus 18, this is going to give us 22. 22 mod 10 is still 2. 10 will go into 22 twice with a remainder of 2. What this effectively means is you don't need the loop. This actually handles that part as well, that while loop that we got to. Okay, so let's develop this solution some. Right? I'm actually going to jump straight to what if we're facing left or what if we're facing right? Well, simply put, if I'm facing to the left, I want my spaces to be negative. So what I'm going to do before I do this formula is do a simple if statement check. If we're not facing right, that means we're facing to the left, I want my spaces to be negative. I'm going to take spaces and actually make it negative spaces. Okay, another way you could express this is 1 times this, right? We can multiply it by a negative number. But as it turns out, you can't just put a negative sign in front of a variable and it'll treat it as a negative. Take a look at this. If we're not facing right, meaning we are facing left, we're going to have spaces become negative spaces. Okay, how does this help me? Well, let's set up the scenario. I'm going to face to the left. Let's move something simple like 3 spots. My position is 4. Actually, let's check this. Are we facing to the left? Yes. Spaces, which is a positive 3, will become a negative 3. Okay. Our current position is 4. We're going to add negative 3 to that. This is going to give me a positive 1, and then 1 mod 10 is just simply 1. Awesome. All right, so this simply handles the moving left aspect of it. Let's try maybe a different number. I'm going to move like 7. We're going to ask, are we facing left? Yes. Spaces, which is 7, will become negative spaces. That is negative 7. We'll do 4 plus negative 7. That gives me a negative 3. Negative 3 mod 10 is negative 3. Uh-oh. That's going to push me out of bounds. Right? I am this far to the left. Let's think about where we should be. If I'm facing to the left and I want to go negative 7, I'm going to go 1, 2, 3, 4, 5, 6, 7. I want to be at a positive 7. Right? Our position at this point is negative 3, but what I want is a positive 7. This is actually really easy. If we're out of bounds to the left, all I have to do is basically add my world length back, right? If we're out of bounds, how do we know we're out of bounds? Well, our position is negative. If it's negative, I'm just going to add my world length, right? We want to go from negative 3 to a positive 7. So I'm going to add my world length to it. I will take position. Is going to be what it currently is plus world length. Okay, and then again, we could shorthand assignment operator this thing to reduce it to that. If we're out of bounds to the left, which we are, we're at a negative 3, we're going to add 10 to that. Negative 3 plus 10 is going to give you a positive 7, which places us there. Why don't we try this out? I'm going to create my bug. It's facing to the right initially, so I'm going to turn it to the left. I want to move, in this example, 7 spaces, and we'll see what happens. Boom, we're at position 7, right? If I move 1 more, we're actually going to be at position 6. Okay. Now, one thought process people tend to have is, like, we encountered something kind of similar before, and we ended up having to do a loop. Like, what if this number is effectively larger than my world length? Like a negative number, but larger than my world length. What if we ended up with like 13 here? The thing is, with the modulus, we're not going to have a number that is larger than the world length. What do I mean? Let's move like a lot more. Let's go like 17. I'm facing to the left. So we would ask, are we facing to the left? Yes. Our spaces would become negative 17. Here, I'm going to take our current position, which is 4, add negative 17, our current value for spaces, right? This is going to give me, what, negative 13. We would ask, how many times does 10 go into negative 13? 1 time with a remainder of negative 3. Right? So the modulus is what's keeping us in bounds. I hope this math checked out. I was trying to do it all in my head. Yeah. The last question that we need to look at is, well, how does this work if I'm facing to the left, but I want to do a negative number? Okay, take a look, because this is ultimately going to handle it for us, and maybe we could have done this with our while loop approach and got there. We're going to step through this, right? Our move is negative 7. We're at position 4. We are facing to the left. So we're going to take our spaces, which is a negative 7. I'm going to take the opposite of negative 7, which is just simply 7. We'll do 4 plus 7. This gives us 11. We'll mod that by 10, which gives us 1. We'll ask, lastly, is 1 less than 0? No, so this doesn't happen. Our final position should be 1, and we'll see what it's supposed to be as well. I'm going to go ahead and run it. Oh, sorry, I should probably, tell it to do that. Let's do this -7. And we ended up at position 1. Is that where we're supposed to end up at? Well, this is going to be tragic if this doesn't quite work. I'm here at 4, and I'm going to go -7. That's going to be 1, 2, 3, 4, 5, 6, 7. Whew. We got there. So as it turns out, this is actually really easy. It handles this part, the forward and backwards part, and if we're facing left or we're facing right. So I feel like this is a somewhat big brain approach. I'm going to get rid of the comments so you got something clean to look at. And it's that easy. It's all stemming from this. The fact that anytime you want to wrap around, you can use modulus to kind of keep you in bounds there. And this works wonders with positive and negative numbers. Okay, the last thing I want to do in this video is this other move method. It's effectively the same thing. My idea behind this move method is it just moves one space, right? Let's plug in a header. It does all this, but it just moves one space. Okay, what is the point of this? It's just like with our overloaded constructor. We're just trying to give the client, in this case the driver, more options. Instead of having to specify a move amount, I just want to be able to just move, and it just move one space. It is the exact same thing, except it's as if this value is always 1. So I'm going to show you something kind of brilliant, and the whole reason that we did this one first. This method exists. I can see it from here. Let's just call that method, but with a very specific number, 1. Okay, what is this going to do? Well, let's get our bug back. Here, instead of doing -7, I'm going to do just a blank move. This is not a syntax error now because this method we just wrote, it technically exists. So we're going to create our bug. He's going to look just like this because we've turned him. So it's facing to the left here, and I'm going to tell it to move. That's going to move one space. Let's see the result, and then I'll talk about why it ends up working or the flow of it. So we were here. I told it to move because we're facing left. We're going to move one space in that direction. Okay, what happens whenever we call this move method? We're going to go inside bug's move method. Right? First thing it does, the only thing it does, is it calls move 1. That's going to jump down here, providing 1 as the value. It then goes through all of the steps to move exactly one space, and then it ends. That's it. This is pretty clever, right? We're able to, as I call it, chain these methods together. And it's part of the reason that I wrote the one that takes more parameters is so that we could just simply chain this one to it. What is the point of overloading this in this way? Is to give people more options. And you've experienced this through other overloaded methods. Substring, for instance, right? There's 2 different versions of substring, one with 2 integers and one with only 1. I could go ahead and tell you that this substring that takes 2 integers, they wrote that one first. The one that only takes 1 integer, all it does is call the other one. It does effectively this. Okay, so this is kind of a technique that does get used in practice, and by thinking a little bit smarter and programming this one first, we're actually able to save some time. What is like the benefit? Well, here, if I update this method, maybe we decide that the way that we move, we want to change it. I don't want to wrap around anymore. I just want my bug to fall to its death. Okay, if I make a change in this method, it effectively changes this one as well, because all it's doing is being chained to it. So that actually helps us long term, while also giving our client classes, such as the driver, more options. We're going to pause there, and in our next video, part 3, surprise, we're actually going to write out the driver so that it looks like the one that I have demoed. I'll see you in the next one.